Hey guys, Mrs. Dan's here. So we're on lesson 2. Today we will be solving equations. If you could copy the objective onto the lines in your book. We like to say that we solve equations using the properties of equality. That's like a fancy way of saying using inverse operations, like whatever you do to one side, you do to the other, but it's like undoing things. So if you can hit pause and go do the do now, and then check with me to make sure your do now is right, that would be great. So on number 1, we have to combine like terms. You get 1x plus 4. You don't have to put the coefficient of 1. On number 2, we have to distribute. You get 6x minus 10. On number 3, I feel like simplifying what's in here first. I don't like how that looks. I would rather it look like 5, and then those brackets really are like parentheses. You could leave it as a bracket or you could turn it into a parenthesis. I don't need the 1 there. I don't need a minus -2. If I do keep change, it's a plus 2. And that looks so much nicer. Now I can distribute, and I get 5x plus 10. So sometimes I like to simplify things before I go and do my distributing. Um, Number 4, I'm going to distribute this -2. The 3x isn't touched. The -2 gets distributed, so it says minus 2x minus 2. And when I combine these like terms, I get x minus 2. Number 5, this is a -1 that's getting distributed. This negative x isn't being touched at first. And when I distribute the -1, I get -2x, and then I get a plus 3. Right? A -1 times a -3 is a positive 3. And then this minus 4x hasn't been touched yet. And then we can combine like terms. So negative x, which is really like a -1x, combines with a -2x and combines with a -4x. -1, -2, and -4 when combined is a -7x, and then I'll just write down that plus 3. And number 6, we have to solve this equation. Let's add 2 to both sides. We get 4x equals 12. Let's divide both sides by 4, and x equals 3. So that's solving. Don't forget, when you check, you write the original equation. The very next step must be to substitute in what you think your answer is. Don't do any kind of math, just do a substitution. So 4, and in place of the x, I put the 3, minus 2. And I'm hoping it equals 10. This is where the check comes in. I do just order of operations when I do checks. So I multiply, and then I subtract these, and on the left side I have 10. Look what I have on the right side, it's also a 10. They really are equal, so it checks. So you do order of operations when it comes to checking equations. And then this is something, maybe you want to take a screenshot of it, put it on your phone. Like, keep this in a place so that you can remember what the steps are. We like to distribute first if there are parentheses. Then we like to combine like terms that are on the same side of the equal sign. Then we like to get the variables to one side by undoing the adding or subtracting, which is an inverse operation, or this undoing of adding or subtracting with our fancy words. We call it the addition or subtraction property of equality. Those are our new fancy words. When we get the constants to one side by undoing, adding, or subtracting, that's also either the addition or subtraction property of equality. It depends on if we're adding or subtracting. But this step 5, when we undo multiplication or division, we call this the multiplication or division property of equality. And then we always like to check. So you know that I kind of skip around when I teach. I don't do every single problem. There's a whole lot of problems here. And honestly, if I just do a few of the problems, you're going to learn the skill that I want you to learn. So today we're going to make sure that we can simplify one side of the equation and then use our inverse operations or those properties of equality to get the variable by itself. So I'm going to do just a few of the questions. I'm going to do 4 of them. So I will do number 1, and I do want to solve and check. So the equal sign is like the center of the equation, and our steps that I asked you to screenshot even says that we're supposed to distribute first if there's parentheses. I see parentheses, I want to distribute. I get 3x minus 21. I'm just going to bring down the equal sign and the 9. Our next step says combine like terms if they're on that are on the same side. These things right here on the same side, they're not like terms, so I can't combine them. So there are no terms that I can combine. Next, it says get the variables to one side by undoing the adding or subtracting. In all of today's lesson, the variables will always still be on one side. So this step we're not doing today. We do have to get the constants to the other side. So when I say the other side, I mean not the same side as where the variable is. So here on number 1, the variable's on the left side. I have to get the constants to the right side. So the plain old numbers. So I have to get rid of this minus 21 by using the addition property of equality. And it's the addition property of equality because I'm adding 21 to both sides. And it's staying equal. That's why it's a property of equality. I'm left with 3x on the left side, and 9 plus 21 is 30 on the right side. Next, I'm going to use the division property of equality because I'm going to divide both sides by 3. So x equals 10. And this is my final answer. Let's just write down a couple of notes here so that you know these new fancy words of ours. So right here at that step, it was the addition property of equality. And right here, what I did to both sides was the division property of equality. You actually do have to know these terms. They have appeared on tests. We're not going to keep on writing it down all day long today, but make sure you get it down here. So when you add something to both sides, it's the addition property of equality. When you divide both sides by something, it's the division property of equality. We still have to do a check, remember? So I'm going to put it right here. If you need to use another piece of paper because it's not enough room, please make sure you have that available. And when we do a check, we start with the original equation. With a check, this is so important for you to know, we never distribute in checks. Never distribute. That's really a never. Okay, you write the original equation, then you substitute in the value of x, then you follow the order of operations. So to do a check, maybe let's write those notes down here with a check. First of all, never distribute. Never, 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 never distribute. So what do we really do? We substitute the value in for the variable. and then we follow the order of operations. A lot of you like to call it PEMDAS. It's really called the order of operations, by the way. So I wrote the original, I substituted. PEMDAS says do parentheses first, so let's do this. So the 3 stays here, 10 minus 7 is 3. And then if I follow PEMDAS, the next thing I can do is multiply, I get a 9. Take a look what's over here, it's a 9, and they're equal. Okay, so follow the order of operations. If there's just a simple number like this 9 on the right side, there's nothing to do, just keep on writing it down. In the end, you should have the same number on both sides. The check is not your answer. Your answer is this, x equals 10. The next question I want to do is number 2. Sorry, my phone keeps on going off. So, number 2, here's the center of the equation. If we go look at the rules, we're supposed to distribute if we see parentheses. No parentheses. Oh, all right. So, I forgot where I was at. I think we said that in number 2, we're up to combining like terms, and it says that are on the same side of the equal sign. So that's why I drew this line down where the equal sign is. All of these things over here are on the same side of the equal sign. They're all on the left side. So if there's like terms on one side of the equal sign, you should combine them. So this 4x and this negative 9x, we should combine to get negative 5x. I'll bring down this plus 3, I'll bring down the equal, and I'll bring down the negative 32. So I did combine like terms that were on one side. Remember, we said the variables are already on one side. I have to get the constants to the other side. I want to get this 3 over there. I actually kind of think about it as moving it. I really want to move it over there. You can't just move it though. You have to do an operation. We have to use our inverse operations. I have to use the subtraction property of equality. I have to subtract 3 from both sides to undo what was here on the left. So negative 5x equals a negative 32 minus 3 is a negative 35. Finally, use the division property of equality. We divide both sides by a negative 5. Just note, whenever you divide, you always keep the sign the same, right? It was negative, I keep it negative, because when I divide this, I get a positive 1x. Over on the right side, a negative 35 divided by negative 5 is a positive 7. We are going to do a check, since it tells us we're supposed to solve and check. So again, I get to fit it over here. If you don't have room, please make sure you use a separate piece of paper. But the original equation said 4x minus 9x plus 3 equals negative 32. Now we substitute. So 4 times 7 minus 9 times 7 plus 3 equals negative 32. Next, you're supposed to follow the order of operations. So I'll do what's on the left side, because on the right side it's just a simple number of negative 32. I can do this multiplication to get a 28. I could also do this multiplication to get a negative 63. I'll bring down the plus 3. I'm going to work from left to right. 28 minus 63. It's going to be negative. I'm subtracting way more than what I have. I'm going to come off to the side here. I don't have a calculator. I need to subtract these things. So I want to borrow. And I get a 35. So this is negative 35 plus 3. And then when I do this, since the signs are different, it's like subtraction again. It's going to turn out to be negative. I get negative 32. Good thing, because look what's over here. Negative 32 does equal negative 32. This checked out. Next number, I'm going to skip all the way to number 7. Number 7 has both distributing and combining. So this is really the final skill that I want you to be able to do today. We'll do one more problem after this, so just so that you have 4 problems that you can look back at. So if we follow the rules, you have to distribute first. So this 2x is going to stay. I distribute the 3 to get 3x plus 12. And the right side just stays as is. Next, I'm going to combine like terms that are on the same side. So 2x can combine with 3x to get 5x. I'll bring everything else down. Then I use my inverse operations. I will subtract 12 from both sides. So the 5x equals negative 15. I will divide both sides by 5 so that x equals negative 3. I'll do a check to make sure I did everything right. I'm actually not going to do number 8 with you, so I'm okay if some of my work spills over into the space for number 8. So I'll do my check here, but I'll kind of use a little bit of the space on number 8 because we're not going to do number 8 today. So you can write down your original equation. I also give you permission to just go straight for the substituting. So I can write down 2, instead of writing down 2x, I can write down 2 times negative 3, and then plus 3. We need to keep these parentheses. In place of the x, I'll put the negative 3, plus 4, close my parentheses, and hopefully all that equals negative 3. Remember, we have to follow the order of operations. Order of operations, so you do parentheses first. And here, these parentheses is nothing to do. But these parentheses, there is something to do. So I'm going to leave this as 2 times negative 3 plus 3 times, and now negative 3 plus 4 is a 1. I'm not going to worry about my right side just yet. I'm going to do my order of operations and do 2 times negative 3, which is negative 6. And I'm going to do 3 times 1, which is 3. Still, I'm going to follow my order of operations, and negative 6 plus 3 is a negative 3, and I say good thing, because the right side turns out to be a negative 3 also. So hopefully you're getting better at checks, even if last year they were hard for you. I expect you to be able to do checks properly. I will not accept your homework if you do not solve and check. I have one more question I want to do with you, number 10. It says think here, and it's because we have to be careful of distributing this negative 3. Right, the 12x, I'm not going to worry about. I am going to distribute the negative 3. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And that equals 48. Next, I have to combine like terms. So 12x and negative 3x is 9x. Bring down the minus 15 equals 48. I have to use my inverse operation, so I add 15 to both sides. So 9x equals 48 plus 15 is a 63. Divide both sides by 9. And x equals 7. We do have to do a check. There's some extra room down here, so I'll do number 10's check right here. So 12, and in place of the x, I'll substitute a 7. 12 times 7 minus 3, parentheses, 7 plus 5, close parentheses, equals 48. If I follow order of operations, I do what's in these parentheses. And 7 plus 5 is 12. Then I can multiply here. And multiply here. And 84 minus 36. This is a 48. And the other side is a 48. And it checks out. So that's the work that I wanted to do with you. Your homework is here, one of these riddle dittos. I'm not asking you to do the riddle. I don't expect you to do the riddle actually, because I think there's too many questions on here for you to do for homework. I like to do like 5 questions, especially since you're solving and checking. So for homework tonight, I really only want you to do number 2. So I'm going to circle this. Number 3, number 7, number 10, and number 14. Now there's really no room on here for solving and checking. So I expect you to go to the next page, page 10. You have a blank page 10 where you can do your work. So remember, you have to solve and check these 5 questions, and you could do all of your work on page 10 in your workbook. It would probably be easiest just to do it right in your workbook, take a picture and send it to me. Better yet, scan it and send it to me. If you want to write on a PDF the way I'm doing it, you can, but sometimes it's easier just to pick up a pencil and do it on paper. I don't want to torture you. So I hope this was good. If you have questions, send them to me, and I'll talk to you soon. Bye.